I've briefly mentioned already an entity called a filter. In this chapter I go on to describe what they are in full detail. A filter is the following. It is a command line utility that has the following properties. As I read out these properties, see if you can relate them to the filter that you've already seen, which is WC. First property is it takes standard input. In other words, it reads information from either the keyboard, from another program, or from a file. Secondly, it performs some processing on the data that it reads. You can think what the processing is that WC does. And thirdly, it produces output based on that input. Can you think of the output that WC produces? Well, let's have a look at that. WC is, of course, a filter. The processing it performs is that it counts lines, words, and or characters. LS, however, is not a filter. It's not a filter because it takes no input. Let's prove that LS takes no input. We'll just have a quick look. If I type LS and press enter, the program runs, produces output, and I'm back to the shell prompt again, which means the LS program has completely finished, and at no point did it ask me for any input from the keyboard. Now you might think to yourself, well, what about the, let's say the -L option? Surely the -L bit is input from the keyboard. No, the -L option is a command line argument. The -L is typed in before I press enter. Before I start the LS program, I've typed in ls -L already. Input is defined, I think you'll recall, as keyboard-based input that is required after the program has been started. In other words, after I've pressed enter on the command line. So what is the purpose of a filter anyway? Well, a filter is used to process the data that is produced by other programs, and also used to process the data in files. So if you like, they are text processing devices. In the next module, we'll examine some very common filters that you'll find in Unix.